ओके 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 बुझिए ठीक है ठीक है ठीक है ঠিক আছে ঠিক আছে
কোথায় যাবো উপরে তো 3 নম্বর রুমে আরে মালিকা ছাড়া ডিগ্রিতে যেতে হবে ड्रेसिंग वाला हॉस्पिटल से पूछ रहा 36 घंटे चला है ठीक है 36 × 200 अभी तो
Eminent speaker, sir, Head of the Department of Chemical Engineering, Haldia Institute of Technology, faculty members, and dear participants. A very good afternoon, everyone, and welcome to the third day of our faculty development program on Industrial Wastewater Management IWWM-2023.
4 बजे चालू है ओके ओके अरे पिंटू को जिस
Organized by Department of Chemical Engineering, Haldia Institute of Technology, in association with IQAC, HIT, Haldia. Dear participants, we are going to start our third day technical session now. Our today's speaker is Mr. Pranav Sinha Mahapatra, Senior Manager at MCPI Private Limited. Mr. Pranab Sinha Mahapatra obtained his BSc Honours in Chemistry, MSc in Environmental Science. He has 25 years of experience. His experience is in utility, plant operation, which includes water treatment plant with RO and DM, effluent treatment plant ETP, cooling tower, etc. His special field is in safety, highways, hygiene, QC, TPM, etc. Mr. Mahapatra is currently working as senior manager at MCPI Private Limited. Today, he will be giving his lecture on industrial wastewater treatment, a sustainable approach towards cleaner environment. Now, I would like to request Mr. Mahapatra to start his speech. Over to you, sir.
Okay, sir. Sir, can you hear me, sir?
Yes, sir. You are audible.
Okay. So,
Sir, make it full screen, your PPT.
how to make it? Sir, it is in full screen now.
No. Full screen, sir. There is a option in the cap sign is there in the bottom.
Bottom, but that is not.
In the bottom,
Okay,
right
that I understand, but that is not active right now.
in PPT, sir. In PPT,
Okay,
you will
in
see.
PPT also. That PPT, you can see my PPT, no? That in the short
PPT is
form?
visible, sir, but it is not full screen.
Full screen. Okay. Now I think it is full screen, no?
No, sir. It is not full screen now.
मेरा था बोल रहे 30 घंटा लेकिन आपका जो फाइल है 1 मिनट सिस्टम में तो अच्छा है ये मन वाला नहीं बोल रहा मैं प्रेसिंग बोल रहा
दिन में चला है 7 तारीख को 00
से निकाल दे रहा हूं
Okay, once I stop sharing, then again I am.
Yes, sir. Yes, sir.
तो हम तो मैंने बोला जो बता दिए मतलब डेटा है मेरे पास तो ट्रेन से हर साल लागत मांगने निकालता हूं उसको पूछा गया मैं ट्रेसिंग हो रहा हूं हम तो मैंने वाला का बोल रहा है फिर भी तो आप लोग जो भी नहीं आप जो भी बोलेंगे उसी का भी बैकअप हो जाएगा कोई टेंशन नहीं
Sir, now it is visible.
Yes, sir. It is visible.
Now visible, no? Okay.
Not, but it is not full screen, sir.
It is now full screen. In my computer, it is full screen. So maybe this much it can be shown. It is now totally full screen in my laptop. So any problem to viewing this?
No, it is visible. So it is visible, but actually not full screen. It is saying.
It is in PPT format. So should I change it to the PDF?
No. PPT is okay, sir. But PPT there is full screen option is there.
You see, now I am changing the slide. It is changing.
No, slide is also not changing.
Not changing.
No.
Slide is also not changing.
Now it is changing, sir.
Changing, no?
Now it is changing.
Okay, so maybe it is taking time, I think. Okay, so I can start now, no?
Yes, sir. Start.
Okay, so welcome to all to the faculty development session on industrial wastewater treatment, basically a sustainable approach towards the cleaner environment. So myself is Pranab Sinha Mahapatra, it is Senior Manager, Utility Department of MCPI Private Limited. So the content of the presentations is that objective and purpose of wastewater treatment, characteristics of industrial wastewater, significance of wastewater treatment, types of wastewater treatment, WWT process flow diagram for MCPI specific, and types of effluent, that is also MCPI specific, stages of WWT unit, that is MCPI specific, and important control parameter and regulation values, and monitoring and observations, and trouble and countermeasure. Sir, can you hear me? Hello?
Yes, sir. You are audible, sir.
Okay.
You are audible.
And slide is visible.
Slide also.
Okay. So now come to the objective of industrial wastewater treatment. So basically the main objective of industrial wastewater treatment are as follows. So basically to extract pollutants like acid, alkali, sulfur, phosphate, etc. To
একপ্লোড করো স্যার বলছি ফুল স্ক্রিন হয়নি জিজ্ঞেস করো ফুল স্ক্রিন হয়নি
so now it is full screen, sir.
No, sir. It is not full screen.
Not full screen.
ফুল
it-
স্ক্রিন হচ্ছে না এর নিচের আইকনে করে দাও
নিচে কোথাও?
স্যার স্যার 1 মিনিট স্যার করে দিচ্ছি
এটাই ফুল স্ক্রিন আর কিছু full screen।
এটাতে ছিল তো
হুম হুম।
জিজ্ঞেস করো যে ফুল স্ক্রিন হয়েছে
No, sir, this is same, whatever is
It
showing
is same. It is same now.
same. So I think this is the full screen in my laptop. No more improvement can be done. So it is visible to you clearly or not?
Yes, sir. It is visible. You can.
Okay, okay. So I should continue it. Okay.
Okay. Okay.
Okay. So the main objective of industrial wastewater treatment are as follows: to extract pollutants like acid, alkali, sulfur, phosphate, etc., to remove toxicants like the lead, mercury, arsenic, cadmium, and to neutralize the coarse particle like organic metals, heavy metals, organic materials, etc., and to cool pathogens like virus, bacteria, fungi, and protozoa. So that the purpose is the quality of discharge water is to improve to reach the permissible level of water to be discharged into the water bodies present in the river, sea, and for the agricultural land, etc. So now coming to the characteristics of wastewater. Basically, there are various characteristics of wastewater, categorically the physical, chemical, and biological. Under physical, like temperature, color, odor, conductivity, turbidity, so solid, suspended solid, dissolved solid, and volatile, etc. And under chemical, it is BOD, COD, TOC. Later I am coming to detail about the BOD, COD, TOC. pH, alkalinity, nitrogen, phosphorus, chloride, sulfate, metals, and dissolved gases, inorganic and organic both. And for biological, it is chloroform, other pathogens, and toxicity, etc. Now coming to the what problem if wastewater is not treated. This is a very basic questions. So actually wastewater having the suspended solid. So what problem if suspended solid present in the wastewater? Basically sludge deposits in the aquatic environment, which actually for low DO and blockage of water flow. And for organics pollutants, because of that DO depletion, marine life destroy, odor and toxicity to humans. For oil and grease, it is the blanketing of aquatic surface, which for low DO also. And pathogens, that is the communicable disease to marine life as well as humans. For nutrient, that is the groundwater contamination and eutrophication, resulting in the huge growth of plant life, causing of oxygen depletion. And the priority pollution like carcinogenicity, causing cancer to marine life as well as the consuming animals, like the cyclic hydrocarbon and derivatives, arsenic, chromium, etc. Mutagenicity, it is the causing of changes in the cell structure, can lead to cancer and other complications like arsenic. And teratogenicity, that is the causing of deformity in the newborn if the parents have used this. And some drugs used by the human and animal which is released. And toxicity, that is the decreased normal activity and growth, single and multiple organ failure, sudden death like iron, manganese, cobalt, mercury, lead, cyanide, etc. So now coming to the significance of WWT operation in the industries. So why it is important for industries to operate the WWT? So basically no direct impact on the production and profitability. It is very clear there is no direct impact on the production or profitability for the industries. And also the huge cost for WWT treatment. For our case, sir, it is the annual expenditure of around rupees 15 crore in our case every year. So it's a very huge cost. Then why we are treating the wastewater? So basically the answer is the government regulation, which is stringent rule we have to obey, must. Social responsibility as a corporate citizen, we have goodwill depend on that, can impact the business if broken and indirectly related to the profitability. And also finally the failure will lead to the temporary and permanent closure of the establishment, that is directly related to the survival. So this is the basic reason for why WWT operation in industries is very, very essential. So basic concept of wastewater treatment is, so basically microorganisms in the river and the sea use the organic matters as their nutrient source. They consume organic matters along with the dissolved oxygen in the water and biodegrade them into substances such as carbon dioxide and water. In the river or sea, the following food chain is formed. Basically organic matter and oxygen is there in the river or sea, and after that it is eaten by the microorganism, and after that it is eaten by the algae, after that it is eaten by the animal plankton, and after that it is eaten by the aquatic insects, shellfish and fish, and finally it is again coming to the cycling, the organic matter and oxygen. So this food chain is being maintained in the river or the sea in the aquatic environment. So this food chain keeps the water quality constant in the river or the sea. If a large amount of wastewater which contains organic matters is discharged from the plants or the industries or from the houses, that microorganism will consume a lot of oxygen in order to biodegrade it. If the rate of oxygen diffusing from the atmosphere into the water is constant, the amount of dissolved oxygen in the water will decrease rapidly. So consequently, microorganisms as well as other aquatic life forms will die because of that oxygen deficiency. So as a result, river and sea will be polluted and living creatures will not be able to live anymore. That is the basic concept. So there are various type of wastewater treatment. Yes, sir.
Sir, I think your slide is not changing.
Not changing. Okay, maybe it is taking time. Now it is slide number 10. I am showing the slide number
it is
10.
3. Now it is showing 3. Slide number 3.
Oh. So maybe there is some connection issues, I think. Just wait. Still 3.
No, now it is 10.
Now it is 10, na? It is 10, na?
Now it is 10. You can continue.
Okay. So maybe there is some connection issues, so that's why slide is moving slowly. So I am discussing with the types of wastewater treatment adopted in various industries. So depending on the industries, there are various type of wastewater treatment. So first type of treatment is the dilution, which is the very easiest method. So liquid or semi-solid in some causes gases that are diluted with the water, so which reduces the COD, BOD and material normal temperature and neutral pH. That is only for water soluble wastes and used for natural resources. And second is incineration, that is the solid flammable or liquid flammable application of heat in the incinerator, reduced amount of waste and to some extent of toxicity. So only use of fuel and secondary treatment of heat and gases is needed. For chemical treatment, that is the solid or liquid chemicals, the chemical reactions to negotiate the toxicity and balance pH, etc. And which actually result is the reduced toxicity and balanced pHs. Then use of chemical is required for the chemical treatment. And for physical, like gas or liquid type of waste, that is filtration, settling, centrifugal action and adsorption, that is result is the reduced solid particulate matter, total suspended solid and order. So this is a settling process, but it is a very slow process. And next is the aerobic and biological, which MCPI industry is adopted. That is the liquid and semi-liquid treatment is possible by use of oxygen. That is reduce the BOD, COD and metals and temperature and neutral pH. So use of air, quick process, high energy consumption, better shock handling capacity. So this is our process. And also another is anaerobic process in absence of oxygen. This is also same treatment of waste is possible and reducing COD, BOD, metals and temperature and pH also. That is also slow process. Cannot handle bulk waste, inferior shock handling capacity, low energy consumption. Methane release can be the used as an energy source. But we are as a MCPI, we are using that aerobic sludge treatment, which is a biological treatment. We call it the activated sludge process. So now I am moving to the slide number 11. Sir, it is showing slide number 11.
No, sir. Still it is 10. Now it is 11. Sir.
Okay. Actually, it is taking time due to maybe connectivity issue. Anyway, so now come to the treated water discharge limit, which is set by the Central Pollution Control Board and our WEPC West Bengal Pollution Control Board also obeying the same norms. So there are 14 parameters basically during discharge to the river. We are maintaining these 14 parameters within the permissible limit. So number one is pH. The limit is 6.5 to 8.5. Number 2 is fluoride, that is 2 ppm. Chromium, hexavalent chromium, it is 0.1 ppm. Iron, it is 3 ppm. Manganese, it is 2 ppm. Chromium, it is the normal chromium, that is a 2 ppm. And suspended solid 100 ppm. And cyanide is 0.2 ppm. Oil and grease is 10 ppm. COD, that is the chemical oxygen demand, is 250 ppm. And BOD is the biological oxygen demand, is 30 ppm. Phenolic compound is 1 ppm. and sulfide as S2 minus, it is 2 ppm, and arsenic is 0.2 ppm. That is the parameter list which basically we are maintaining continuously 24 into 7 into 365. And also we have a online server. So in the online server, that data is being directly transferred to the CPCB server and WPCB server. So that is only for 4 parameters: pH, BOD, COD, and TSS. Now I am moving to slide number 12. Sir, it is slide number 12.
Yes, sir, it is 12.
Okay. So let's come to the chemical oxygen demand. So chemical oxygen demand is a very important term used in WWT. So basically this is the milligram of oxygen required to chemically oxidize the organic contaminants in 1 liter of wastewater, that is called the COD. The COD measurement by use of manganese and chromium as a reagent. Generally COD Mn, that refers to the oxygen consumption as KMnO4 at 100 degrees centigrade, and COD chromium refers to the oxygen consumption as K2Cr2O7 potassium dichromate at 100 degrees centigrade. COD is basically an indicative of the organic matter contamination, just as BOD. However, from the viewpoint of pollution control, BOD value is much preferable. But the BOD measurement requires the much longer time, approximately 5 days, and needs expensive equipment. So in this respect, COD measurement takes shorter time and its instruments are low price. So that's why COD measurement is preferable rather than BOD. Next, coming to the BOD. So it is slide number 13.
Yes, sir, it is 13.
Okay. So BOD is basically the biochemical oxygen demand. So BOD refers to the amount of the dissolved oxygen consumed for the propagation of the breathing action of the aerobic microorganism in water. So it is basically represented in the unit of ppm as kg, and BOD is an important indicator of the organic matter contamination in water. If the contamination is big, the microorganism which breathe, eating, and the organic contents as their nutrients will be active. That is, their breathing action will become active and the amount of dissolved oxygen they consume will increase. On the contrary, if the contamination is small, they will not become active and the consumption of dissolved oxygen will decrease. Therefore, a larger BOD indicates a larger organic matter contamination and may as such be used synonymously with organic matter. Moving to the slide number 14. It is slide number 14, no?
Yes, sir, it is 14.
Yes. So let's come to the dissolved oxygen. Dissolved oxygen is also a very important parameter. So in the process of the BOD removal in the activated sludge, oxygen has important functions. So the thing which is used for adjusting target is dissolved oxygen. Unit is ppm, parts per million, in the solution of the aeration pond. It is preferable that DO value remains within a certain range. Too high DO value does not make the removal speed of BOD, and it is not economical also, because if we maintain the DO value higher side, we have to put more air into the system. So that means high energy consumption. So in order to raise the DO value, the amount of airflow must be large and energy consumption will be large, and WWT treatment cost is also will be higher side. On the contrary, too low value will cause the oxygen deficiency and make the activated sludge jumps in the aeration pond die out. Generally, DO value is preferable in the range of 2 to 4 ppm in our system, but it is a standard. Now I'm moving to the slide number 15. Hope it is visible. So
Yes, sir, visible.
yes, now come to the activated sludge process, which is MCPI specific process. So this is a activated sludge process we call. This is a biological process. So basically in the biological process, 3 processes takes place simultaneously. First is the sustenance of microorganism. What is microorganism? Microorganism plus organic matter plus oxygen in the aeration pond in the bioreactor. So that reacting produce the microorganism plus carbon dioxide and water. Then next step is the growth and propagation of the microorganism. That microorganism plus oxygen plus nitrogen, that is large and new microorganism is being produced, and along with the carbon dioxide and water. And last stage is the destruction of microorganism, that is biodegradation. Then come to the dead microorganism plus oxygen, then carbon dioxide, water, nitrogen, and heat is being produced. Because microorganism is continuously keeps generating, in that case that MLSS, mixed liquor suspended solution concentration will increase and sludge will overflow from the system, because sludge settling property will be poor in that case. So we have to continue extraction process needs to be continued in the biological system to remove the dead microorganism from the system. So in this process, COD conversion to biological cell through metabolism, relatively less toxic, high COD waste and high efficiency, oxygen, microorganism and nutrient containing nitrogen is also escaping. Now I am moving to the slide number 16. So basically this is a conventional activated sludge process of wastewater treatment. That is, influent is coming to the aeration tank, then after that clarifier is there. From clarifier the supernatant is being discharged to river, and return activated sludge is being again put to the aeration pond, and some part is waste activated sludge, that part is going to the sludge decanter for the sludge and water separation. And this extended aeration tank, basically oxygen supply is there from the aeration blower, and that oxidation is being takes place. This is the aerobic zone and clarifier is the anaerobic zone. So that's why always return activated sludge is being recycled to the aeration pond from non-aerated zone to aerated zone. Let's come to the MCPI specific WWT. So this is our process flow. So slide number 17 is visible.
Yes, sir, it is visible.
Okay. So this is a MCPI specific process flow of our wastewater treatment. So basically categorically we have 4 types of effluent: effluent A, B, C and D. So these 4 type of effluent is coming to our equalization pit. Equalization pit is nothing, all the effluent pit is mixing here. This is a concrete pit, there is a aeration system and all the equalization mixing here, and homogeneous COD is being converted and pH balancing is there, and from equalization pit through pump we are supplying this effluent to the aeration pond. Aeration pond is basically a biological reactor, oxidation reaction is taking place, carbon dioxide and water is being formed here. So this for oxidation we are putting that aeration blower, from aeration blower that air is coming, and we are maintaining DO here, dissolved oxygen, around 2 to 4 ppm. So after that, that microorganism is biodegrading in this system, and after that is supernatant coming to the secondary clarifier. This is the clarifier, and from clarifier some part is recycled back to the aeration pond. So this is anaerobic zone, so that's why sludge will die if long time exist in the secondary clarifier. So that some activated sludge is again recycled back to the aeration pond, and some part is going for the decantation for the sludge extraction, and supernatant is coming to the effluent water pit for final discharge to river. And for the supplying nutrient to the bacteria, we are actually supplying the urea and STPP. Urea supplying the nitrogen and STPP is supplying the phosphorus to the bacteria for their healthy process. Urea is a nitrogen supplier and STPP is a phosphorus. STPP means the sodium tripolyphosphate. Let's moving to the slide number 18. So this is a very simple schematic of MCPI WWT for easy understanding of all. That effluent A, B, C and D all is coming to the equalization pit, and from equalization pit it is distributing to, we have a 2 parallel aeration pond are there, aeration pond 1 and aeration pond 2, and feed is being distributed equally to aeration pond 1 and aeration pond 2, and there are 2 parallel clarifier in parallel operation, clarifier 1 and clarifier 2, and clarifier 1 overflow and clarifier 2 overflow coming to the same system, and finally it is being discharged to the river, and supernatant again going to the river, and the recycled sludge in coming to the aeration pond in both the cases. So this is a very simple schematic to easy understanding of all. Let's moving to the slide number 19. So MCPI categorically have different type of effluent. So if we describe the different type of effluent, so effluent A, B, C and D. What does it mean, effluent A? Effluent A means the process specific, that wastewater from the catalyst recovery process and the cleaning washing process. And how much COD is being, this COD is 8,000 to 10,000 ppm, and effluent D is the sanitary waste. So this COD is very less, this is 300 to 500 ppm. So this is our categorical effluent of MCPI specific effluent, effluent A, B, C and D. And total COD basically coming to the aeration pond from these effluent. Let's moving to the slide number 20. Hope it is visible, na? Slide number 20.
Yes, sir, it is visible.
Yes, sir. So now coming to the stages of wastewater treatment of MCPI specific. So first stages is the feed section. The feed section is consist of the effluent storage tank. Effluent storage tank, why necessary? Because WLT operation, you know, there is 24 into 7 into 365 operation is required. Otherwise, all microorganism will die. But every plant, every industries have, there is a annual shutdown maintenance is there for around 30 days, 40 days maintenance is there in a year. So that time no effluent generation from the process will be there as process stopped. So that's why effluent storage tank is necessary to feed food to the bacteria in the aeration pond. And effluent transfer pump, equalization pit. In equalization pit, all the effluent are coming, mixing by aeration and pH balancing. And for activated sludge microorganism, the living condition of pH is 7.5 plus minus 0.5 minus 7.5 to 8 are preferable. From equalization pit, final effluent or equalization is being fed to the aeration pond by the influent pump for biological oxidation in the aeration pond. This is the feed section. Let's moving to slide number 21. So this is the stages of WWT in the aeration pond. This is the second stage. The aeration pond is made of concrete. There are two aeration pond in MCPI WWT. Aeration pond on parallel operation. In bioreactor, both are bioreactor in which the complex hydrocarbons are decomposed by microorganism into simple compound of carbon dioxide and water. For proper reaction in the reactor, is a parameter is considered called the residence time. Here in case of bioreactor, also similar property termed as mean cell residence time. In MCPI, we maintain MCRT around 22 to 25 days. In aeration pond, we maintain dissolved oxygen 2 to 3 ppm and pH 7.5 to 8 and temperature less than 40 degree. This we are maintaining in the bioreactor, I mean in the aeration pond. Let's move to the slide number 22. So this is the sedimentation pond, I mean clarifier. So this is the last stage. So upon decomposition of the liquid containing mixed liquor suspended solid is being overflowed to the second sedimentation pond. Sedimentation pond is the clarifier. The purpose of this unit is the volume reduction of sludge thickening, and the process is called the gravity thickening. And influent pipes enter the sedimentation from the bottom and empties into the feed oil at the top of the tank, and from where influent the overflows slowly into the tank. The bottom of the feed oil should end well above the sludge blanket interface to minimize the turbulence and resuspensions of the solid. The suspended solid are separated by gravity and the collected to the center by a rotating sludge collector. Sometimes scum is formed when sludge does not settle owing to the low density. In sedimentation pond or clarifier, we maintain the sludge depth more than the 1000 ppm. Basically, sludge remain from the surface the 1000 mm deeper, so that supernatant directly overflow to the river. Let's moving to the slide number 23. So let's come to the important control parameter, which is also the MCPI specific, that is the pH, temperature, dissolved oxygen, micronutrients. COD is to N is to P. There is a ratio, COD is to nitrogen is to phosphorus. Basically, we maintain 100 is to 2.2 is to 0.6. F by M ratio, that is the food by mass ratio. Hydraulic retention time, mean cell retention time, residence time, solid loading rate for clarifier, and oxygen consumption rate, that is the OCR. Later I am coming to detail on that. Let's moving to the slide number 24. Some important terms used in WWT and their significance. So first is DO. DO is a dissolved oxygen. This is a residual oxygen left in the liquor after consumption by microorganism to convert COD. In MCPI we maintain it to 2 to 3 ppm. Next is MLSS. MLSS is the mixed liquor suspended solid. That is the amount of microorganism in unit volume of the liquor. It is the residue left after heating the liquor at 102 to 105 degrees centigrade till all the moistures are removed. Next is MLVSS. MLVSS is mixed liquor volatile suspended solid. That is the amount of volatile matter in unit volume of the liquor. It is the difference between the residue left after heating the liquor at 102 to 105 degrees centigrade and at 500 degrees centigrade till all the moistures are removed. Let's see MCRT. MCRT is the mean cell residence time, the average life of microorganism in a system. Next is SVI, that is the sludge volume index. It is a ratio which indicates the settling property of the liquor. Next is hydraulic load. Hydraulic load is the total liquid flow into a system, especially in clarifier in unit time. Let's moving to slide number 25. Hope it is visible to all.
Yes, sir, it is visible.
Okay.
Slide number 25.
Okay. So next is SLR. SLR means solid loading rate. What is it? It is the total microorganism entry into a clarifier in unit time. Next is denitrification. Denitrification, it is the removal of various forms of nitrogen from the reactor. And COD. What is COD? It is the amount of oxygen required to convert the contaminants of unit volume in the system. BOD, it is the amount of oxygen required to support the metabolism and growth of microorganism. In our case, COD by BOD around 1:5. F by M ratio, that is the food by mass ratio. It is the ratio between the amount of COD fed into the amount of MLSS present in the system in unit time. Next is OCR. OCR is oxygen consumption rate. It is a ratio which indicates how efficiently microorganisms are converting COD to harmless substances by using oxygen. This is a very important parameter for us whenever we can check the health of the microorganism. Next, moving to the slide number 26. So basically for supplying nutrient, I mean nitrogen and phosphorus, we basically dosing some chemical into the aeration pond. So first is urea. Urea for the nutrient supply, basically nitrogen to bacteria, protein, and STPP is the sodium tripolyphosphate. This is also act as a nutrient for phosphorus to bacteria. And ferrous sulfate, sometimes in alternate days we are dosing in the aeration pond for the coagulation purpose, and 98% H2SO4 for pH control purpose. Because whatever I mentioned, that pH we have to maintain 7.5 to 8 in the aeration pond. And our all effluent become almost high pH, only 1 or 2 effluent is low pH. So our overall pH is little bit higher side. So that's why sometimes mainly during the shutdown time, that H2SO4 dosing is required to maintain the pH of the aeration pond. Let's moving to slide number 27. Now coming to the monitoring and observation. So this is our MCPI specific. So we monitor the pH of the aeration pond and control range in 7.5 to 8. So countermeasure what we have to take if it is abnormal. So check pH of the feed wastewater. If pH drops rapidly to less than 7.5, then stop the feed of the wastewater and H2SO4. If pH drops or raises gradually to less or more than 7.3, check and adjust the amount of H2SO4. And for DO, if DO we maintain normally 2 to 3. If more than that, adjust airflow by air feed valve to every block. When that PCB is fully open, stop one aeration blower. When PCB is fully closed, that standby aeration blower we have to start. So like this way, we control the dissolved oxygen in the aeration pond. Temperature we maintain normally 35 to 38. So at high temperature, basically what happened, that check the temperature of the feed wastewater and adjust the wastewater flow to sludge cooler. There is a sludge cooler for cooling the sludge in the aeration pond. And likewise, we are maintaining the temperature of the aeration pond to keep microorganism healthy in the system. An MLSS concentration, that mixed liquor suspended solids concentration, basically the content of microorganism in the system, we maintain normally 6000 to 7000 ppm. That if not maintained, then adjust with the return sludge flow, and in worst case we have to add microorganism from other plant. And our case, the treatment feed COD is the 12 ton per day for old plant, and is the 30 ton per day for the new plant. And if beyond that, sometime we have to adjust with the dilution water. Let's moving to the slide number 28. Then I will discuss that MLSS to COD conversion calculation, how MLSS to COD conversion is possible by the microorganism. So microorganism, that chemical formula considered to be that C5H7O2N for the nitrogen and C118H70O9N17 for phosphorus. And formula for MLSS to COD conversion is basically that oxygen is consumed by the microorganism. So C5H7O2N plus 5O2, that producing the 5CO2 2H2O plus ammonia. Ammonia actually generated in the process, and later on during denitrification process, the nitrogen is being removed from the system. So typically we can found that 113 kg of sludge, I mean MLSS, requires 160 kg of oxygen to biodegradable or decompose. So 1 kg sludge requires that 1.42 kg O2. So 1 kg of sludge is equivalent to 1.42 kg of COD. So like that way, we have to, our COD load is 30 ton per day for new plant and 12 ton per day for old plant, and accordingly we have to maintain the MLSS in the system. Let's moving to the slide number 29. So this is the feed COD load calculation. How we calculate the feed COD load? This is very, very important because our design is based on the feed COD. If more than the design effluent load is going to the aeration pond, then WWT upset will occur. Maybe bacteria will die and COD treatment efficiency will deteriorate, and outlet COD will become increase. So what is the calculation? So basically total feed COD load to WWT is the sum of individual effluent load, which is normally calculated as mentioned below. So basically previously I told we have a 4 types of effluent, effluent A, B, C, D. So just I summarize the calculation that suppose wastewater, that washing flow is 10 ton per hour, that recovery catalyst washing flow is 7.5 ton per hour, effluent B, which is the major contributor, flow is around 95 to 100 ton per hour, effluent C flow say 14 ton per hour, effluent D is a sanitary waste, say 7 to 8 ton per hour. So now these all effluents having various degree of organics, and hence COD loads are different. Already I discussed the COD load of different type of effluent, where contributed the RC COD is maximum but RC flow is less. Effluent B COD load is minimum, that is 2000 to 3000, but its flow is high, so COD contribution also high. Let's coming to the detailed calculation of that feed COD. So this is slide number 30. Hope it is visible to all.
Yes, sir, it is visible.
Okay, so that washing WWT COD is 5000 ppm, the RC is 25 to 30,000 ppm, effluent B is 2000, effluent C is like that. So therefore COD contribution from individual effluent are basically that flow into that COD into 24, because that flow is ton per hour. So in ton per day, if we converting ton per day, it is into 24 and divide by 10 to the power 6. So this is around all the effluent, individual effluent load is like that, 1.2 ton COD per day, 4.5 ton COD per day, 4.56, 1.5. So if we sum up all the individual effluent COD load, then we come up with the total COD load in the system. So like this way, every day we calculate the feed COD, because this is very important for the healthy system. Let's moving to the slide number 31. This is the calculation of solid loading rate. So how to calculate the solid loading rate? if we maintain aeration pond sludge MLSS is 6000 ppm and clarifier inlet, it is clarifier means that aeration pond to sedimentation, that overflow is suppose 100 ton per hour and recycle is 300 ton per hour. The inlet solid loading rate to the clarifier will be 6000 ppm into the total recycle flow, I mean 400 divided by 1000, around 2400 kg per hour, and clarifier area is pi d square by 4, that is the typically 471.4 meter square. So solid loading rate is that 5.2400 by 471.4, that is the 5.091 kg per meter square hour. This is the solid loading rate, but typically we maintain the solid loading rate from 5 to 6 kg per meter square per hour. This is very much necessary, otherwise what will happen, sludge settling property will be poor, maybe that sludge depth will not be visible in the clarifier, and with the supernatant from sludge will also overflow, which increase the total solid content will increase the at the outlet, and also COD will increase. Let's move to the slide number 37. This is the mean cell residence time. Mean cell residence time is also a very important parameter for us, because this is the life of the microorganism. This is a life cycle. So we can predict the life cycle of the microorganism, because typically we have found that if life cycle is more than 25-26 days, then microorganism become inactive. So basically they are not fit for biodegradable. So key factor of MCRT are the volume of aeration pond, MLSS of the aeration pond, feed flow to the dehydrator, I mean decanter, feed MLSS of the dehydrator. So how to calculate it? Say sludge in aeration pond tank, that volume 10,100 meter cube, MLSS average is 6000 ppm. So total solid is 60.6 ton. And average our that wasting rate, sludge wasting rate through decanter, it is 10 meter cube per hour. Then MRS of the clarifier is 8000 ppm. So wasting rate is 80 kg per hour. So MCRT is total sludge volume divided by the total wasting rate. So it is around 757 hours, so equal to 32 days it is coming. So we maintain normally 25 to 30 days. If more than that, that wasting rate we have to increase. That wasting rate, suppose I calculated it with 10, considering 10 ton per hour. In that case, we have to increase the sludge wasting rate. Let's moving to the slide number 34. So this is the food by mass ratio. So food by mass ratio is the food means that COD and mass means the MLSS. COD load, suppose as a reference it is 10 or 11 ton per day. Volume of the aeration tank is 10,100 meter cube. MLSS average is 6000 ppm. So total solid is 60.6 ton, and MLSS in the tank is 60,600 kg. So F by M means 11,000 kg per day divided by 60,600 kg, so 0.18. So typically we maintain food by mass ratio 0.15 to 0.2 per day. Let's moving to the slide number 35. So what is OCR and its significance? OCR is the oxygen consumption rate. So what it signifies, it gives basically the oxygen consumed by the sludge for its metabolism. So by measuring this OCR, we can estimate the health of the microorganism. So this is important to understand the metabolic activities of the sludge and control the WWT operation. Reduction in OCR means the reduction in metabolism provided COD load is constant. So sludge sample is taken. How to measure it? Sludge sample is taken in a 500 ml beaker. From one side air is supplied and diometer is dipped into the measure to the O2. Air is supplied till diometer reading become constant. So almost saturated DO is around 8 ppm. So after air is stopped, do start decreasing. Automatically, gradually it will decrease as per the consumption of the microorganism. So at the time of interval, the values are plotted on the graph till again do becomes constant. DO becomes constant. The difference between initial and final is taken for the calculation. Unit of OCR is that gram DO per kg per MLSS hour. Let's move to the exact calculation chart in slide number 36. So this is the time wise plotting. Suppose saturated oxygen was 7.6 in 0 time, After 5 minutes, it is 6.7. After 10 minutes, it is 6.1. After 15 minutes, it is 5.7. Accordingly, up to 30-40 minutes, whenever till then it is constant value, till then we measure it. So DO minimum is T0 minus T50 by 50, that is 7.6 minus 1.7 by 50, that is 0.118 DO ppm per minute. OCR is equal to the T0 minus T50 by 50 into 1000 into 60 by MLSS. So it is coming around like this. So in this way we calculated OCR. So to predict the microorganism metabolism rate. Let's moving to the slide number 37. So in the slide number 37, we discuss about the various type of WWT parameters, their significance, effect and countermeasures. So DO is a very important parameter for WWT. Basically from our DCS distributory control system, we can check the DO from the remote, and accordingly we maintain the 2 to 3 ppm. That is the directly measurable, that calculation, that if low, that insufficient COD conversion, gradual decrease of MLSS. If high, that is the wastage of energy, huge generation of MLSS. And effect is low is outlet COD is high. If DO is low, outlet COD will be high, treatment efficiency will be less. And if high, that is the wastage or decantation will increase, wastage of energy and also decantation will increase, because microorganism growing rate will be higher in that case. Checkpoints is for low, that aeration blower, that is the supplying equipment that we have to check. And for high, that is the low feed COD and sludge characteristics we have to check. And countermeasure is for if low, that the check aeration blower condition and distributed aeration system is there, that we have to check. And for high, there is the reduce air and check the sludge in the microscope. And pH, it is also directly measurable. We maintain 7.5 to 8. For low and high, both cases decrease in MLSS will occur. For low and high, outlet COD will gradually increase. And low for effluent B, there are various effluent we are supplying to the pit. In that case, there are effluent characteristics we have to check and effluent quality we have to check. And for low and high, dilution with water and information to our that supplier, I mean process is supplying the effluent. So their system any abnormality was there, that we have to check with them. And temperature is also directly measurable. So temperature decrease the treatment rate if decrease, and high also decrease the treatment rate and sludge wastage rate. In both cases, outlet COD will increase. So we have to control the temperature by the sludge feed to the sludge cooler and also the effluent feed to controlling the reaction. Let's moving to the slide number 38. For MLSS, it is also directly measurable. We maintain 6000 to 7000 ppm. If low, that is the insufficient COD conversion. If high, that means air micronutrient consumption pond will increase and energy consumption will increase. And if low MLSS, then what effect will be there? Outlet COD will be high. If high, in that case, total operation cost will increase. So we have to balance all the thing. And COD, BOD, that is also directly measurable. So COD, we normally, our case, less than 100 ppm we maintain, and BOD less than 15 ppm we maintain, even if the regulation figure is more high. And for low COD, we inefficient WWT operation. If high, that is regulatory failure, pollution of aquatic life, and major water pollution will be occur. And for low case, our effect will be wastage of resources, and for high case, temporary and permanent closure notice may come from the WPCB or CPCB. And F by M ratio, we maintain 0.2 to 0.2.5. So if low, MLSS may be maintaining on the higher side, feed COD too low. If high, then feed COD too high, MLSS may be maintaining on lower side. So like this way, we maintain the WWT feed. In that respect, there are various parameters we are maintaining in this way to keep microorganism healthy and treatment efficiency will be normal. Let's coming to the troubleshooting. So troubleshooting is also a very important part for WWT operation. This is slide number 42. Hope it's visible.
Yes, sir, it is 42.
Okay. So there are various trouble occur in WWT. So, but efficiently we handle the WWT after proper troubleshooting and taken countermeasure. So for low pH, suppose pH suddenly low from process side, abnormal effluent comes, so maybe pH low. So confirm instrument is okay, because for measuring pH, there is an online analyzer, pH analyzer is there at the site, and that data is transmitting to the DCS from the remote control room, and check that different effluent, that parameters, all the pH we check, and finally we resolve. For high temperature, sludge cooler and cooler performance and effluent feed quality we check. For low DO, there is a root blower what supplying the air, that condition, current, everything we check, physical condition abnormality, and effluent also quality we check, and check the aeration system, the distributory aeration system is okay or not, and check the total COD load not exceeding the design value. Our COD design for the new plant is 30 ton per day, and old plant it is the 12 ton per day. So if COD feed is more than the design value, in that case also low DO will occur. So we have to check the feed COD at all the time. And for low sludge depth means basically sludge depth we measure in the clarifier. After the aeration pond, there is a clarifier. Basically, from clarifier, the supernatant water is being overflowed to the final effluent water pit, and finally to discharge to river. So sludge depth is important. If sludge depth is low, in that case sludge is basically floating on the surface. In that case, we have to check the NO2, I mean nitrogen, that NO2 paper, that nitrogen dioxide. If there is a denitrification process is not occurring well, in that case that sludge floating may occur. Check solid loading rate. That solid loading rate is very high. In that case, sludge depth will be low. If MLS is not high, MLSS concentration is very high, then also sludge settling characteristic will be poor. In that case, sludge floating chances will be there. High turbidity of sedimentation pond outlet water, that is also we have to check the effluent load not high, check aeration pond is not violent, I mean aeration is not violent, and confirm free cell availability in the flocks. Through microscope we have to check. Next, coming to the actual 44 slide, so WWT pictorial view, that MCPI, that WWT stage wise. So this is the equalization pit. Slide number 44 is visible to all.
Yes, sir, it is visible.
Okay,
Yes, sir.
so this is the actual pictorial view. So what we discussed before, that this is the equalization pit, this is the feed section. That equalization pit, all the effluent you can see from the picture, that all the effluent is coming to the equalization pit, and aeration system is there, and pH balancing is occurring here. And after that is this effluent, mixed effluent, is being fed to the aeration pond, which both the aeration pond are in parallel operation. So feed to the both the aeration pond, and this is the sludge color. You can see the sludge color of our aeration pond, and this is, you can say, this is the oxidation reactor or bioreactor, and here we are maintaining the dissolved oxygen, here we are maintaining the pH, here we are maintaining the MLSS, everything we are maintaining here. This is the heart of the WWT. This aeration pond is the heart of the WWT. So we maintaining aeration pond all the parameters very carefully, and we control it very carefully, and we take countermeasure also very carefully. So in this way we keep our WWT become healthy, and our treatment efficiency is around 98%. So around 97 to 98% COD reduction is there. If you see the 30 ton per COD, and also around 5,500 ppm, if we transfer it ppm 5 to 5,000 ppm, and we getting the less than 100 ppm. So COD conversion rate is very good, around 97 to 98% ppm is efficiency is visible for us, all the cases. And this is our clarifier, both in parallel operation, from aeration pond 1 to clarifier 1, aeration pond 2 to clarifier 2, and finally discharge is common from aeration clarifier 2 discharge and clarifier 1 discharge coming to that ditch, and finally come to the effluent water pit, and then going to the final discharge to river. So this is the entire pictorial view of our WWT. If you get the opportunity, maybe may of your representative may come, and we will support to visit our plant in some times. So if we discuss about our performance of MCPI WWT at a glance, you can see is the last financial year from April 22 to March 23. So we have treated that. This is the green bar is showing the COD load of the old plant, and blue bar is showing the COD load of the new plant. So around on an average more than 30 ton COD we have treated for the new plant, and around 12 to 15 ton COD we have treated for the old plant. So if we look at the final discharge, so that is the feed part, and this is the final discharge whenever after treating from the aeration pond. So that COD is coming to the almost, our regulation is 250, but we maintain is below 100. You can see from the last financial year April 22 to March 23. So that final discharge COD is almost all the cases is below 100. So our treatment efficiency is very high, and we are maintaining it very well, even if very high cost for this aerobic system. WLT operation is very high cost. Previously told around 10,000 rupees per ton COD treatment cost is there. So around we are investing around 12 to 15 crore in a year. So this is all about my presentation, and thank you very much for your attention. So if you have any questions, please.
Thank you, sir, for sharing your knowledge. I hope our participant will be benefited a lot from this lecture. Sir, there are some questions from our participants.
Okay, please.
I'll read it for you.
Okay, please.
There is one question: whether any catalyst recovery process is there from waste sludge?
No, actually catalyst recovery process is exist in our the process plant, catalyst recovery process. So in our WWT system there is no catalyst recovery process is there.
Okay, sir. One more question is there, sir. What is the further treatment of waste sludge from activated sludge process?
No, waste sludge treatment is there. Waste sludge actually basically through decanter. Whatever told that decanter basically some part of the around 15 to 80% of MLSs we are extracting from the system, and through decanter it is separating the solid and liquid, and after that it is fed to the sludge dryer. So sludge dryer volume reduction process is occurring. So from sludge dryer the solid sludge is coming. The sludge is being actually we supply to the that for co-processing Ombuja Cement Limited and Odisha Cement Limited. Presently what we have the system. So like this way that solid sludge treatment is being conducted by us.
Okay, sir. There is no more question. No more question is there. Thank you so much, sir. Thanks a lot.
Thank you very much for your attention.
Thank you, sir. Kuila sir. Kuila sir, are you here?
Okay, yes, I'm there. So, Mr. Pranab Mahapatra ji.
Yes, sir. Yes, sir.
Thank you very much for giving us your valuable time.
You are most welcome,
And
sir. You are most welcome.
many of us have gathered so many information about the wastewater treatment, and
also
that will help us for carrying out their future projects.
Sure, sir.
So
Sure,
thank
sir.
you once again. Thank you very much.
And also, if your people is very much interested to see our wastewater in some point of time, you just make a call to me, and I will get approval from our strategist, and after that we can arrange your site visit. Not many people, but if really interested people, suppose 4 to 5 people, they may come, and
Okay.
I will serve them. Okay.
So yes, definitely it's a nice proposal. So definitely I shall share with our colleagues too. So definitely we shall visit your plant, and actually we are visiting your plant.
Yes, sir. Yes, sir.
In a regular way, yearly at least 1 or 2 in a year. So sure.
Now,
It's a
for
great
the mutual
proposal.
benefit, definitely for the mutual benefit, that industry and institution, that collaboration is very much required, and our company also very much willing to collaborate with the institutes. So maybe there are so
Academies.
many program also have been now collaboratively is organizing. So maybe last
Yes,
days.
yes, yes.
Yes.
Already one uh, mm, this kind of assignments we have got.
Yes, sir. Yes. Right.
That is continuing. Actually, process has already been started.
Yes.
So sure, 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 sure. So thank you very much.
Okay. Okay. Thank you. Thank you very much.
Thank you, sir.
Okay. Thank you.
Now, dear participants, with this we are ending today's session here. Tomorrow we have our fourth day of FDP, and the speaker is Dr. Amitabh Bandopadhyay, Professor, Department of Chemical Engineering, University College of Science and Technology, University of Calcutta. He will be giving his lecture on strategies of industrial wastewater treatment.
So thank
Now,
you, sir. I am leaving.
yes, sure, sir.
Okay. Okay. Thank you very much. Have a nice day.
Thank you. Now, dear participant, attendance link is live and it will be active for half an hour from now. So please mark your attendance within half an hour. Thank you, everyone. Have a nice day.